So in this problem, we're told to assume that the smallest measurable wavelength in an experiment is 0.610 femtometers. And what is the maximum mass, so we're solving for mass in kilograms, of an object traveling at 451 meters per second for which this de Broglie wavelength is observable. So we know we're going to have to use the de Broglie equation because we're asked for mass and we're given velocity and a wavelength. So here's our de Broglie's equation. Lambda, or the wavelength of an object, is equal to h, or Planck's constant, divided by the mass of that object times its velocity. So the wavelength has to be in units of meters, our mass in unit of kilograms, our velocity is units of meters per second, and we know that Planck's constant has units of joules times second. So what I'd like to do is rearrange this equation because I'm solving for mass. So I'd like mass all by itself on one side of the equation. So I'm going to multiply both sides of the equation by mass, and I'm going to divide both sides of the equation by lambda. And so now I have a rearranged equation. So mass is equal to Planck's constant divided by the velocity of the object multiplied by its wavelength. So here's Planck's constant, 6.626 times 10 to the negative 34th joules times seconds. The velocity was given as 451 meters per second, and the wavelength 0.610 times 10 to the minus 15th meters. My wavelength has to be in unit of meters, and femto means 10 to the minus 15th. So this is just an easy conversion from the given value to the value or the unit of meters. So when I plug all these numbers into my calculator, this is the value that I get. And I've rounded to 3 sig figs because both my wavelength and my velocity have 3 sig figs. But before I go any further, before I actually put this into my answer box, I've got to make sure that my units are correct. So let's take a look at our units. In my numerator here I have joules times second, and in my denominator here I have meters per second times meter, which is meters squared per second. Since my second is in the denominator, so a fraction under a fraction bar, we remember from how we divide fractions. This fraction bar means to divide. When I divide by a fraction, I multiply by its reciprocal. So the second, when I simplify my units, actually goes up to my numerator. So after I simplify my units, I have joules, and I'll put a little thing on there. I have joules times second squared per meter squared, which really doesn't look anything like a mass unit. So what we're going to have to remember is that a joule can be expressed as kilogram times meter squared per second squared. So when I express my joule in terms of kilograms and meter squared per second squared, I can see that meter squared cancels out and second squared cancels out. And the unit that I'm left with is kilograms, which is the mass unit that I'm looking for.